Alright, so today guys, our goal is to talk about graphing. So I did give you some graph paper, right? If you forget where the graph paper is, or you forget yours at home, you guys know where to find it on my website. Where do you find it on my website? In the download section? Yeah, it's not going to be in the free algebra, because I really tell all my classes, it's the coordinate graph. This is exactly what you have as well, with the backside too. So, just in case you lose yours tonight, you can find it right there. Alright, linear equations and graphing. First of all, I need to understand, when I say linear, do you understand what shape you're graphing? Line. Line, that's right. Oh, now look at the word. It says line R. We're creating a line. That's very simple. Okay, so that's the first thing I need to make sure is clear with you all about graphing. There are many different ways to graph. We're going to be walking through it. As all of you are going to be taking the high school placement exam, this chapter in particular, really pay good attention to because this is going to be in the first bit of your algebra course as well. So it's important here. So we're going to be graphing lines. And the first thing I want to chat about with you in our warm-up, we looked at the problem and x minus 9 equals negative 2, and I said, double check with me, is x equals 7 a solution? And we plug this 7 into x, right? So you replace that right here. And you said, yep, 7 minus 9 is negative 2. It checks out, yes. That's all I'm going to ask you to do first off, is to check now, not just x, but x and y right here together to try to see if it fits into the equation. It's going to give you the equation. So you're just going to fill it out. So what's the y value? 3. Okay. What's the x value? 2. 5 times 2 minus 7. So ask yourself, what is 5 times 2? 10 minus 7. 3. Is that equal? Yes. So you right? Yes. That's all we do to check it out. It's a solution, just like you did on the warm-up. Okay, let's try that out with the next one. 0 and negative 6. What's the y value? 0. The y value is negative 6. Okay, what is 5 times 0? 0. Minus 7. Negative 7. Does negative 7 equal negative 6? No. No. So you write them. It's not a solution. Your turn. Plug in 4 and 14. Right. What do we think? No. What does it equal from the other side? 13. Good. So 20 minus 7 is 13. So definitely no on this one. This is how you can do a lot of double checks what we're doing today. Let's never really take that. The next thing I want to chat with you all about is how do you make sure it's an equation, and I also want you to be able to tell the function. Remember, what's the important rule? You must have nodes meaning x value. So it's important. We talked about making a machine yesterday, right? Yeah. So you put in, say, 3, and you will get out, say, 5. If I put in a 3 again, I should still get out the same 5. Now if I put in 4, and we'll get 6. What's the rule, by the way? What's the excellent here? So 5. Now it is also possible that I could put in, say, 4 and also get out 5. But each time I'm putting in 4 or 3, I'm still getting out 5, right? I'm only getting the one y, and that's important going on for today of what I want to chat with you about. So first of all, I want to tell you you're going to have a linear equation if you have one rule. It will be an equation with a line shape. You know it's going to be a linear equation. It's going to get a line shape if you have an x or a y with the equation. And what's really important about that is that it's x to the first or y to the first in the equation. There are no exponents. You can write that down as well. Now you will have a linear equation. Let me put it one farther. It will become a linear function with one rule. Can be harder. Again, here we're looking for x or y with no exponents. Now, remember how we were talking about how you're always taking out a y? Every time you're getting out a y in that machine, you're getting out a y. Every single time you put something in, you must get out a y. Here's why it's important. You must always have a y value. So in order to be a function, this must say have a y. It must have a y to the first. We'll explore that a little bit more later, but I want to ask some questions to tell me yes or no to the function. Here's question number 1. Is this a function, yes or no? It has a y and it has an x, so it's works right here. We're going to have a line. And there are no exponents, so yes, it is a function. Let me change it. Let me put a square on it. Is it still a function? No. Is it still a linear function? No. In fact, it will make U-shape, so this is now no. What if I had said y equals 5? Is this a linear function? Has y? No. Does it have a y? Yes. Yes. That's all you need to this guy's yes. What if I said x equals 5? Is it a linear function? Yes. Does it have a y? So it's a linear. Oh, it's linear. Okay, but my question is it a linear function? No. 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 No y. What if I said x minus 2 is equal to y? Is that a linear function? What if I said x cubed equals y? No. So they will not make that last one not a linear function, is a linear equation. No. Alright, so the next thing I want to do is I want to take a look at some graphs. The first type I want to talk about are when there's only the y by itself. So like, let's do y equals 3. Y equals 3. So when you're doing this, I'm going to teach you to do things today. What I'm essentially saying when I do points like this, I can put in anything that I want. I want some negatives, I want 0, I want some constants. So I'm going to do 2, 1, 0, 1. What this is saying, there's nothing to plug into that. No, so no matter what's my y? 3. Oh. So if I start to graph the points, let's see what she has to do. Line. So type line. What do you have? Type of line. Okay. You guys keep saying the word linear. I know it's a line. What type of line? Okay, I know it's a function. What type of function? Horizontal. That's the word I'm looking for. Alright. This will happen anytime you have the y by itself. You must have to go through the y-axis after you. So y by itself will give you a horizontal line. And And I would like to remember that by saying why like the sky. Why like the sky? Why? Okay, so in fact, I find that making a table on this one is really ineffective. Because anytime you see the y by itself, you know you're going to get a horizontal line instead of just with the y-axis. So what if I said y equals 8? Let's put on the same direction. Or what I go through? 8 on the y-axis like this. What if I said y equals -2? So each time I'm going to have a horizontal line. And what if I wrote y equals 0? Do you remember that you just draw a thicker line on the x-axis? So all of those are going to be horizontal lines. So don't even draw because I just want you to be able to recognize y like the sky, y goes to the y-axis, gives me a horizontal line. If that's the case, what do you think that, now let's move on to x equals 3. If y was horizontal, what do you think? These are going to be vertical. And let's talk about why. If I did put it on the table, so I can understand why. No matter what y is, x will always be 3. So I go to 3, -2, 3, -1, 3, 0, 3, 1. You see how I'm building that up to that vertical line? But again, the table, if I can be wasteful, I want you to remember that it's vertical and it goes through the x-axis. The x-axis, because it says x right there. Okay, so we're doing the next vertical line. Now, before I continue on, let's tie this back. Why is this one not a linear function? Because it doesn't have a y. Why? Look at the picture. If I ran a vertical line through that, how many times would it pass through? Oh, 1,000 million times. Let's go with more than 1,000 forever. There's so many times. See how it fails that vertical line test? Because the x value is always 3. Think about what we saw on our table as well. It was always 3. The x value is 8. This is the only line that is not a function. Wait, so this isn't a linear function or this is a linear equation. It's a line. But it's not a function. Alright, let's do another one of these. What if I said x is equal to -5? I'm going to draw a vertical line going to which axis? X-axis right through the -5 right here. And what if I said x equals 10? That's just what the over here. What? Oh, alright, here's how I remember that x is vertical. Alright, so I had to use this phrase. X ray for your vertebrae. Actually, that is something on my very first your vertebrae is vertical, so straight as now. Semi-vertical. So that will help you. It's going to be X ray for your vertebrae. All right, now these are special. The other ones that I want to talk about today are not going to be just x by itself or y by itself. So here's where tables are going to be about, I do need a table, so I'm going to give you an X or Y. So I'm going to say Y equals X. So here's something good. That is my table. What values are you going to put into your table? Remember, you put in the X, choose what you want, but I want some to be negative, some to be positive, and one to be 0. So negative 2, negative 1, 0, 1, negative 2. Okay, now, all we're going to do is plug it in. Someone plug it in. Plug in negative 2, y equals negative 2. If you plug in negative 1, y equals negative 1. 0, 0, 1, 1, 2, 2. Because it's saying they're equal to each other. That's what it's saying. So if we look at our line, we start here, we make negative 2, negative 2, negative 1, negative 1, 0, 0, 1, 1, 2, 2, and keep going on in both directions. Get a nice line. Not vertical, side. So, yes. Two reasons why. Does it have the vertical line text? Yes, it does. Okay. Second reason why, does it have a Y? Does it have an X? Yes. Well, this is really has a Y, right? Third reason, whenever you plug in just to get out, just plug something in twice to get a Y value. Now, all this work earlier this year, when the Y was not by itself. Everyone wants to get the Y by itself. Yeah. This is wrong. So your very first step to get the Y by itself, we'll call it, put it in linear form. That's called getting the Y by itself. So all that work. So how do you get this Y by itself? Minus the 2x to the other side. It's a positive 4. Now we need to make our chart. Plug in anything that we want. But I want something to be negative. I want to be 0. To be positive. Okay, so now we're going to plug it in. This is why I had you set it up in this formula, so that when you plug it in, the answer that you get, you can write it. So here we go. Negative 2 times negative 2. We talked about this one. Positive 4 plus negative 2 times negative 1. We talked about positive 2 plus 4. Negative 2 times 0. Plus 4. Negative 2 times 1. Negative 2 plus 4. You guys know the times again? 8, 6, 4, 2, 2. 0, 0. Why do you guys want negative 2 times 2? No. Negative 4 plus 4. Alright, so now we're going to go ahead and graph negative 2, 1, 6, 0, and that's 4. 1, and that's 2. 2. I don't have a clue for you. If one of your points, if you have this line come down like this, and all of a sudden this point is like way out here, something's totally wrong. Go back and check it out. You can plug things back. Keep practicing more of those.
So after the dot, I usually just draw the arrow like kind of like a square after the box, like that, all the way through the entire graph. That is just, I'm just saying. Oh, that is just.
So that you should get now for you on. So, for instance, All right. Let's do one where, let's see here. Let's do one where, let's do 3x minus y is equal to 5. Now remember, this class that recognizes is y. No, you guys like right? Okay, so how do we get the negative y by itself? Minus 3x to the other side. That's a positive 5. And now do we go flip, flip, flip? That's what flip, flip, flip is. So you divide 32 by negative 1, positive, positive, and negative. Oh, okay. Take your table. Anything you want. If you want some negatives, 0, get some positives. That's the whole reason to remove the balance on all sides. All right, this week coming to you. 3 times negative 2. Negative 6 minus 5 more. Right? Also negative 1. 3 times negative 1. Minus 5 more. More. 0. 3 times 0. Minus 5. 1. 3 times 1. Minus 5. Negative 7. 3 times 2. 7. 3 times 2. Minus 5. 1. Notice the pattern? What are you doing? Minus 3. Plus 3. Go back. You said positive 3, right? Plus 3? Yeah. Go back to this. You said there's a pattern of this. Minus plus minus. So what was the pattern of this one? Minus. Minus 2. Plus 5. What's the pattern of this one? Plus 3. Oh. Okay, so here we go. Count these. So negative 2 and negative 11 are slightly off our graph. Here, negative 1, negative 8. So, oh goodness. Right. Okay. All right, I want to do one more with the fraction type. Evil fraction. Okay. Let's do x minus 4y is equal to 8. So again, the first goal is to get that y by itself. What's the first one we have to do? What's our first goal? Minus the x to the other side. X by itself. No, always y. Always x. That's why you're looking here. Okay, now what? This one? That is all negative. Y equals positive x over 4 minus. All right, now, here's the thing. When I put my table on this one, I know that I'm going to be dividing by 4. Right? Numbers. So I will get 8. Yes, you can do 16 and 20, but they're not on the graph. So I just want to 0 quarters. Now we have nice numbers so we can put negative divided by 4. Negative 2 minus 2. Just flip it. Negative 4 divided by 4. No. Is 1. Minus 2. 0. 0 divided by 4. Minus 4. 4. 4 divided by 4. 1. Minus 2. Negative 1. We get one of this. 0. We lose 0. 8 divided by 4. 2. 2 minus 2. And 0. Now, I want to be very careful. Well, getting a pattern because I chose certain methods. But, let's take a look at why. What's the pattern?
Yeah, no, that's how
We're going up 1 for every 4 numbers. Up 1 for every 4 numbers. Look right here in this one. What was the pattern? What did you do? Plus 3 for every 1 number.
oh, so that means for every 4 numbers. So like
What was the pattern on this stuff? We went
plus
minus 2 for every 2. Minus 2 numbers for every 1. We'll come back to that pattern. Alright, so let's finish drafting this. We have negative 8 and 4. We have negative 4 and negative 3. 0, negative 2. 1, 2, 1. Alright, one more time. You have several goals in your course tonight. Goal number 1. You're going to plug it in and tell me if it's a solution or not. It's going to tell me yes or no. Goal number 2. You're going to tell me if it's a linear function, yes or no, just by looking at it. Why? Sorry, let me replace it. It has a y and the x has no exponent. Alright, your first goal is to start graphing. You get x by itself or y by itself. I don't want you to do a table. I just want you to go x-ray for your vertebrae and tell me x going through the x-axis. Vertebrae going through the x-axis. If you get a y, I want you to say to yourself, y like the sky, and I want y horizontal through the y-axis. And if you're getting an x and a y in there, that's when I want the table to start. I want you to get the y by itself first, if it isn't already. Give yourself points. 5 points. Alright. So we're using these. Yes, you can use those.
you want every single problem?
Every single note.
I don't think that's